Welcome to Pre-Calculus. Today we will investigate solving rational inequalities, focusing on algebraic and graphical strategies to write solution intervals for the inequality. We'll take a look at two examples, and we'll start with number one. So I want to solve the inequality x plus 5 over x plus 8 is less than 0. One way that we can approach solving a rational inequality is to treat it as a function and look for zeros or x-intercepts and vertical asymptotes as we begin. So that's how I'm going to start here. And I'm going to begin by looking for x-intercepts. So we know that x-intercepts are places on a graph where the whole function has a value of 0. Another name we give to an x-intercept is a 0. And the way we find those is we set the factors of the numerator equal to 0 and solve. We're going to set the factors of the numerator equal to 0 and solve. So I'm going to take my numerator here. This is a very simple rational function. I only have one factor up there in my numerator, and it's x plus 5. So I'm just going to do exactly what I've set out to do. I'll set it equal to 0, and then I want to solve for x. In other words, I want to find the x value that would make the numerator of this fraction 0. If I can do that, 0 divided by anything except for 0 is going to be 0. And that'll give me a way to compare left and right, which parts are less than 0. So I'm going to subtract 5. And I see that I've got an x-intercept or a 0 at x equals negative 5. So what I'm going to do is I'm going to set up a graph. And I'm wanting to graph this function, but really kind of specifically looking for these x-intercepts and asymptotes. So I'm going to place that x-intercept here at negative 5. And at that point, I'm not going to graph any more of the function, but I just want to see that that's where the graph crosses the x-axis. We'll kind of fill in the picture in a moment, but for now, that's just going to be a landmark point for us. Now, I also want to find vertical asymptotes. So remember, for a vertical asymptote, that's where the denominator of a function attains the value of a 0. So if I think about how to find vertical asymptotes, it's similar to what we did to find zeros. The only difference is that I'm now going to set the denominator factors equal to 0 and solve. So like we did, I'm going to set the factors of the denominator equal to 0 and solve. Now, when I look at my denominator, it also is fairly simple. It's just x plus 8. So I'm going to do like we did with our zeros. I'm going to take x plus 8, set that equal to 0. And again, I want to solve. So that's easy to do. I'm just going to subtract 8 from each side. And that gives me the location of my vertical asymptote at negative 8. So again, I'm going to place that on my graph as well. So 5, 6, negative 7, negative 8. And I'm going to sketch that vertical asymptote in place. Now, the last thing that I need before I go get a rough graph from Desmos is I want to just see where any horizontal asymptote is. And remember, to find a horizontal asymptote, we're comparing the high powers in my numerator and my denominator. So I'm going to say here, I'm going to find a horizontal asymptote. And to say how I'm going to do that, I'm going to compare the high powers of x in numerator to the denominator. So as I look at my function, I've got x plus 5. That's an understood power of 1. In the denominator, I've got x plus 8. That's also 1. So recall, if my powers are equal, my horizontal asymptote will be the fraction of the coefficients on those two high-powered x's. Since my x's don't have coefficients, I'll supply a 1 for each. And that gives me this equation, y equals 1 over 1. And I can reduce that down to 1. That was the case when my powers were the same. So the only other instance where I would have a horizontal asymptote is if the numerator was a larger power than the denominator was a larger power than the numerator. And in that case, I would have set right at the x-axis at y equals 0. But if they're the same, the horizontal asymptote would shift like this one. In this case, this one shifted up to 1. So what I need now is I just need to see where does my rational function fit in that framework of asymptotes and the x-intercept 0 that I've got graphed there. So I'm going to write this function down, and I want to go just basically decide which side the two pieces of the rational function, where to place them, and then I'll come back here and then I can interpret to solve the inequality. So let's just switch over very quickly to Desmos. And I am going to treat it as a function. So f of x equals, and then for my numerator, x plus 5, denominator, x plus 8. And so I see my graph showing up there, and I can see the places where my asymptotes are. So y equals 1, that's my horizontal asymptote. And then x equals -8, that's my vertical asymptote. So all I need to check is where the pieces of the rational function are placed. On the left, that blue line, especially if I grab this and kind of scoot the graph over, the left side is above the horizontal asymptote. The right side is below. So that's really all I need to see. I'm going to go back to my notes screen just to sketch in what we've seen here on Desmos. So on the left, the rational function is above that horizontal asymptote. On the right of the vertical asymptote, it is below the horizontal asymptote. So that's enough for me to see how to solve my inequality. So I just need to look at what the inequality is saying. It's saying the graph, x plus 5 over x plus 8, so that's the green curves that I've placed. Where is it less than, strictly less than 0? So if I'm to locate that on my curve, I'm just going to highlight the parts of the graph that are below the x-axis. And that would include this part that is right close to my vertical asymptote all the way up to my 0. And that really tells me the interval to record. So I'm going to record that interval. I'm going to do so in interval notation. So that vertical asymptote at -8, that's where this function really hits a wall. On the other side of -8, it's all above the x-axis, so that part I'm not going to include, but I'm going to include from -8 over to my 0 at -5. Now I do need to ask myself at -5, do I include that x value or should I exclude it? Since my inequality is strictly less than, that graph is strictly less than 0 up to -5, but not at -5. At -5, it actually equals 0. So I wouldn't put the bracket there. I will put parentheses. And I can write that as well in inequality notation, but here in pre-cal, we do want to emphasize the interval notation. So I'm going to let -8 to -5 suffice for us. All right, so that was a simple rational function, but it helped us to set out kind of a strategy that uses both algebra and graphing in order to come up with the solution interval. Let's take a look at a second example of a more involved rational function. So here I've got x minus 1 over x squared minus 15x plus 56. And I'm interested in where that rational function or rational expression is greater than 0. So I'm going to set out the same tasks. So remember, my first task is to find any x-intercepts. And the way that we're doing that again is set the numerator equal to 0 and solve. So this numerator is x minus 1. So I'm going to do exactly that. X minus 1 equals 0. And I want to solve that small equation by adding 1 to each side. So I get right away that x equals 0. I'm sorry, the function equals 0 when x equals 1. So just like we did in previous example, I'm going to start graphing this function with an emphasis on the x-intercepts and also the asymptotes. So here's 1. And I'm going to just mark that on the graph. That is where I have a 0. So the graph passes through the x-axis at 1. Once I've got that in place, I then want to find any vertical asymptotes. And that's where I set the denominator equal to 0 and solve. Now, one thing I'm noticing in my denominator on this question is that it is not factored. So what I should do first is I should factor that, and then I would set each individual factor equal to 0. But I'm going to set it up first in the unfactored form. So I'm going to take the denominator x squared minus 15x plus 56, set that equal to 0. So to solve that quadratic, I'm going to try to factor it. So I'm looking for two numbers as I place my x's. Those will multiply to x squared, so that takes care of my first term. I need two numbers that multiply to 56 while at the same time adding up to negative 15. And that's that classic x factor pattern. What two numbers multiply to the c term 56 but add to the b term negative 15? And I can see right away that that's going to be negative 7 times negative 8. Negative 7 times negative 8 multiplies to 56. The negatives cancel. But when I add them, negative 7 plus negative 8, that adds to negative 15. So there's my two factors, x minus 7 times x minus 8. So I want to solve each of those. Set each of those equal to 0. And solve those little equations. In this case, I'm going to add 7. On the other equation, I'll add 8. And I get two vertical asymptotes, one at positive 7, one at positive 8. So like I did with my 0, I'm going to place those on the graph. So 2, 3, 4, 5, 6, 7, and 8. So these are very tightly spaced vertical asymptotes. But no matter, we can place them pretty easily here on our graph. All that's left for the framework of the function is to find the horizontal asymptote. And remember from our last example, that's a comparison in the high powers above and below. So in our previous example, we saw that the powers were equal. Both of the powers were high power of 1 in the numerator denominator. So that's where I take the coefficients. So I'm looking here, my high power in the numerator is a 1, high power in denominator is a 2. So that's the second case that we mentioned. If the high power is below, the horizontal asymptote is at the default position at the x-axis. So I'm going to record that here. So this is a comparison of the high powers. Here I found the high power was below in the denominator. And that's a nice case because I don't have to do any additional algebra. I'm just going to say that's at the x-axis. And the equation for that would be y equals 0. So I'm going to sketch in that horizontal asymptote. So that's right there at the x-axis. So again, I've got my framework. I have my 1, 0. I've got my two vertical asymptotes. I've got my horizontal asymptote. just like I did before, I want to decide where the function falls. So I'm going to write down the function, and again, I'm going to go to Desmos to get a picture of the graph. Where is it with relation to these asymptotes and the zero? So let's go see over on Desmos. We'll clear out the old function and type in our new function. So this is f of x equals x minus 1, and I'll put the unfactored form, x squared minus 15x plus 56. And I will go to the kind of the home place here. And so I'm seeing that like the asymptotes we found seem to be pretty accurate. If I put the horizontal one in, y equals 0 at the x-axis, that seems to be pretty accurate to the graph. One thing I want to notice, so if I find 1 on my graph, so I see that that is a 0. And if I were to trace up, I can tell I'm on the rational function there. So what I want to see is what happens on the left side of 1. I can see on the right side that function is above the x-axis. Left of 0, so if I just trace on the graph, I notice that it actually crosses through the asymptote and approaches it from below. So I can see that the y value for all these points to the left of 1 is negative. So it's unusual for a graph to do that, but definitely we do have rational functions that do cross the asymptote and approach it from the opposite side that it crossed it. So I'll just keep that in mind. On the left of 1, it's below the x-axis, the y values are negative. To the right of 1, it's positive. The only other thing I need to check are my vertical asymptotes, so x equals 7 and x equals 8. So I can definitely see on the left side, the function is positive. On the right side of 8, it's positive. I'm curious about what's happening in between 7 and 8. So sometimes you just need to zoom out. And if I zoom out sufficiently, in fact, what I can do is take a smaller x interval. So if I went from negative, let's go from negative 20 to 20. And the reason I do that is I want to see what's happening between 7 and 8, but I need sufficient room in the y to do so. So I do see that part of this function that is between 7 and 8 is entirely negative. It exists down there in quadrant 4, bound by those 2 vertical asymptotes. So that's enough for me to see. I can go back to my graph and then interpret to solve that inequality. So I'm going to head back. Again, what we just need from Desmos is where do we place the graph. So I kind of want to emphasize things here. So on the left, this graph is below the x-axis. It passes through the x-axis at 1 and raises slowly up along that first vertical asymptote at 7. There's a piece of the graph that's between 7 and 8, but it's entirely negative. And then the function picks up positive on the right side of that vertical asymptote at 8 and continues along the upper side of the x-axis to infinity. So let's interpret this and then write our inequality. So again, I'm going to just highlight the places. I need to see which inequality I've got. So the last one was less than. We were looking under the x-axis. This one is greater than. So I'm looking for the parts of the graph that are above the x-axis. So it would start here at my 0 and include this upper piece up to the vertical asymptote at 7. And also this upper piece of the function on the right side of 8 all the way to infinity. So definitely I need to write a union for this solution set. So the way I'll write it is from 1 Again, I'm not including one because the inequality itself is strictly greater than. That first piece on the left goes from 1 up to 7. Hits that asymptote, never crosses it, never touches it. And then I'm going to unify that with that right-hand piece of the function that's above the x-axis. That begins at 8 and persists until infinity. And again, once I have that written, I'm going to box it, and that is complete. Thank you for joining for this investigation of solving rational inequalities. I'll let you solve your own rational inequalities. Thank you for joining. See you soon.